we look at the microcontroller. How microcontroller is going to handle the square wave that is given to it, and then producing the output display of some number with some units and so on. Now, the fundamental idea is to measure the frequency. So, we have to do counting over 1 second typically, so or 100 milliseconds. So, we know that 8051 has two 16-bit timers, and they can be used as counters. They can be used as counters also. I hope that we remember the difference between counter and timer, right. So, whenever the signal clock is from outside, we say that it is a counter, right. So, we need to use the timers in counter mode because it has to count the external pulses, because the signal is coming from outside the frequency meter, and the zero crossings are converted to square wave, and those pulses or those transitions have to be counted. So, we have to use timer in the form of a counter, right. There are two timers available. How many timers we need to use as counters? One. For counting we have to use one. So, two timers, I will just write down here two timers. So, we use one timer as counter for counting external pulses, and the other timer as timer for deciding what is called as the gating period. Now, what do we understand by gating period? We know that frequency is nothing other than pulses over how much time? Number of pulses over 1 second, correct? That 1 second has to be accurate. If that 1 second is inaccurate, then your frequency reading will be inaccurate. Suppose you have 1 kilohertz signal, we know that it has 1000 pulses, 1000 cycles per second. But if your 1 second period itself is not accurate, then it will give inaccurate readings. So, you need to use one timer to count the pulses which are coming from outside the frequency meter, and the interval 1 second interval has to be generated by the microcontroller itself. So, accurate 1 second interval has to be generated by microcontroller, and that for that we need one more timer, correct. If you do not want to use one more timer, you can generate this by using simple delay routine. Write a delay routine which will give you exact 1 second delay or very near to 1 second delay, and that will do your job, right. We will have both approaches. Fine. So, what will be the logic that will go inside the microcontroller? So, look at what we did. We talked about the zero crossing detector, we tried to replace, we thought about replacing that by Schmidt trigger. We did not actually replace that, we will do that later on. Now, we decided to use 8051, we wanted to use on chip hardware for that, and we know that on chip hardware is there, 16-bit timers. One timer as counter for counting external pulses, the other timer as timer for deciding the gating period, which is typically 1 second or 100 milliseconds or 10 milliseconds depending on the range. Anyway, we will talk about this. Initially, we will assume only 1 second because it is easy to understand. 100 milliseconds we will take it after some time, right. And then we also said that instead of using second timer, you can write delay routine itself. So, the logic is something like this. The logic will be, what is the logic? What is the logic? So, logic is clear the timer. Now, do we know what is clearing timer? Clearing a timer? Yes. So, it is equivalent to saying TH0 is equal to 0 and TL0 is equal to 0 as far as C programming is concerned. But if you want to write in assembly language, you can also write move TH0 comma hash 00 and move TL0 comma hash 00. Everybody understanding this? So, this is clearing some timer. You may use timer 1 also. Instead of TH0, you can write TH1 and TL1, right. So, the important step is clear timer. Then second is start the timer. It means allow the timer to count. Allow the timer to count, right. So, before that we will set the mode, I will simply write down set the mode of timer, as what? Counter, right. So, we forgot that, we add that now. So, step number 0 is set the mode of timer as counter. Which timer? You can decide on your own. We start with timer 0. Then second is clear the timer, then start the timer. When we start the timer, it will be allowed to do counting. Counting will start, then wait for 1 second. Wait for 1 second. Now, how to wait is our choice. You may wait by simply killing time by using delay loop, or we may use one more timer. We fire the timer, we load the timer to have a delay of 1 second, and after 1 second that extra timer will interrupt the processor, and that interrupt routine will take care of displaying the frequency, right. That approach will decide afterwards. We will go by simple approach first and know the limitations of that, and then it will obviously motivate us to go to the second approach, right. Wait for 1 second. Now, what shall you do after 1 second is over? Stop the timer. Very good. Stop the timer, because to read the timer you need to stop it first. Stop the timer, right. Then read the timer. Read the timer. After reading, display the value. Right. After displaying the value, what to do? Jump to 1. Jump to 1. So, it will again clear the timer, again start the timer, again do the same thing, right. Now, with this logic, how frequently the frequency value will be updated? Once in 1 second, right. Right now it is okay. And what it will indicate? Will it indicate hertz value, or will it indicate kilohertz value, or will it indicate megahertz value? It is going to indicate hertz value, right. So, it is going to directly show the hertz value.